Welcome back to my channel where we start a lot of projects and never actually finish any. I want to show you an upgrade we made to the battery project. We added Twilio and some SMS capabilities so we can be notified via SMS in about 5 seconds if the battery started discharging. I also wanted to showcase kind of how we put this together, some of the code behind the scenes and the tools that we use to build the battery project. We have more ideas in the works. Some of those are arriving in the mail shortly. Be on the lookout for a video for those in the future. However, I want to start with looking at how this was put together. Let's get in close here. So here we have the NodeMCU and here we have the ADS-1115. A comment in the last video, why did we use the ADS-1115? I did not know this, I'm just a big fan of it. Someone had mentioned that this one is more linearly consistent than the ADS baked into the microcontroller. Honestly, I chose this because of the precision. We can bring this down to 16x and we can get to that sub microvoltage measurement, which in a 20 amp shunt with a 75 millivolt drop, that is important. How do we wire this up? We have the SDA going to D2, and we have the SCL going to D1. We have VDD going to a 3.3 volt, and then we have ground going to ground. Very important. I think that's what killed this. I think I had one ground going to my battery backup and my other ground going to the computer, and something happened. I blew the fuse in my room. Let's just not talk about it. How do you wire this up? Here is a 20 amp 75 millivolt shunt. I am going to take the lead that is closest to the charging source, and I'm going to place that on my A1. I then take my lead that is closest to the battery and I place that on ground. This configuration and the code provided below is now measuring the voltage drop across a shunt. There is some configuration. Let's get to the tooling and then the code. One of the most effective tools that I have, I actually printed it and it took about 3 minutes to print. It's this little adapter that connects one of these pinouts for a breadboard to the probes of my multimeter. They're almost on there all the time. Rarely do I actually remove them. If maybe I'm doing some type of home improvement job, I just slide them off, go do what I need to do, and I slide these back on. It's just an exposed wire kind of crammed into the end of a little 3D printed tube. It works extraordinarily well. Some of the digital tools that I use, I have a Fluke 110 Plus and an old Pixel 5 mounted on the wall. The Pixel 5 is plugged directly into the microcontroller, observing the output from the microcontroller using this software. I find this very effective. Rather than spanning a USB cable across the room to the computer, possibly introducing some type of ground issue, instead I can see the millivolt drop across the shunt and I can see the output also measuring the same thing directly from the microcontroller here. Let's take a look at the code. Keep in mind it is available on GitHub for you to download. The new feature, text message capabilities. So we have a new function here, send text message. And down below, when we meet a certain condition, we will send a text message via Twilio. Let's get into that. So kind of reviewing everything from up top, here's our includes. Down below, we have some constant variables where we may copy some of those constant variables into global variables. We define all of our functions. If you're not familiar with C++ or Arduino, there's a million and one resources out there. However, this is built in such a way that you can pretty much just load it to the Arduino and configure it properly, and it's good to go. In our setup function, we're going to go ahead and establish a serial port. We're going to connect to the Wi-Fi. We're going to download the battery configuration. We'll get into that in a second. We're going to initialize the ADS-1115, and then we're just going to print that we're starting. So getting into the battery configuration, let's take a look at that. I have 3 batteries deployed across my house right now. I have my development unit that I have currently plugged in. I have a deep freezer, and I have my internet. And each of the deployments have a different battery capacity, a different shunt, and millivolt drop across them. And I may or may not be interested in receiving text messages from those particular deployments. So looking back at the code, we jump into our loop function. We have an LED that just blinks to tell us when it's taking a measurement. We do take a measurement. We're going to calculate the rolling average across 5 measurements. And the reason for this is because, pause for a second. So I had this big long-winded thing to say.
Point of the matter is we're going to calculate over a rolling average of 5 measurements because not all APCs seem to have the same charging and discharging characteristics. From this chart here, you can see that it's kind of all over the place and I'm not even quite sure what it's doing. And so we're going to smooth that out so that way there's nothing anomalous occurring that gives us a false positive. We're going to start the microcontroller by taking 5 quick measurements, and then from there we get into the fun stuff. This is where things get really fun. So we know a lot of things about our deployment, such as the shunt resistance and the interval that we took the measurement. We have a stopwatch between the start and stop of every measurement. So we can actually calculate the current, the amperage usage in hours or amp hours, and the used capacity of the battery. And if we know the minimum and maximum range of our capacity, which is configured in Mongo, then we can calculate the remaining percent and how many hours are left according to that measurement in time. We then can convert that to seconds, and we can then get that in remaining battery life formatted as a string that we can then present in a dashboard. This is the new functionality that I'm really fond of. This is receiving a text message when the current is measured greater than 2 amps. Because we take a measurement every second, or we attempt to, there are some latencies in there. Because we take a measurement nearly every second, we don't want to send a text message every second, so we do have a delay on that. However, we do send a text message when the current is immediately reversed. This gives us the immediate notification that power has been restored to the deployment and the unit is now charging. This is helpful because for rolling brownouts, you may have a loss of power and then the power is restored only a few seconds later. You don't want any egregious delay that prevents that second message from being deployed. We set the SMS variable to false. That way, if for some reason the power is lost again almost immediately thereafter, we do receive another text message indicating that the deployment is discharging. When we were reviewing the digital tools that I use, this is the serial output that you observed on the Pixel 5. Finally, the most exciting part, we write the variables that we're interested to Mongo. Let's take a look at that. Here we have in real time the documents being written to Mongo for each of the 3 deployments that I currently have live. Here is the development environment that I have plugged into the computer right now. Disregard the measurements right now because it's actually not plugged into a battery, so it's just kind of floating all over the place. Here I have a deep freezer and it's currently showing a negative current draw, which indicates that the battery is charging. This is a 9 amp hour battery. When the battery's charging, you really can't rely on the remaining time. While we're on the subject of Mongo, let's talk about app services. So we have 2 app services deployed. There's a lot of them here. You can ignore most of them. So we have battery management and battery upload. Navigating into battery management, you can see that we have an HTTPS endpoint that is secured by a secret that is deployed in the secrets file. We'll get into that in a moment. And we have a function that it calls. And here is the function that it calls. This code is available in the GitHub. Most importantly, we're downloading the configuration by the MAC address. Taking a look at battery upload, you can see we have a similar HTTPS endpoint, also with a secret configured inside of the secrets file, and a function that it calls. Again, very similar JavaScript function. Here, we're just inserting the one document. In both of these circumstances, be sure that you're using the user ID so that way it inserts successfully. Let's talk about the secret file. If you're not familiar with how to upload C++, specifically for Arduino on GitHub, there is a library that is hidden from you, and that contains all of the secrets, the things that I don't want you to know. I do have a template secrets file for you to populate and use. However, at the root directory of your projects, you have a libraries directory. If that doesn't exist, create that, and then create a directory for Arduino secrets where you have the Arduino secrets.h file where you will have your secrets configured. And that's everything. It's very simple. There's 1,000,001 tutorials out there, and believe it or not, a majority of this code was written by GPT-4. I'm not a C++ developer. I'm not an electrical engineer. I barely know what I'm doing. However, it works very well and it's checking out with my Fluke and other technologies that I have to verify that my measurements are correct. I have these deployments throughout my house and I plan to deploy more. Stay tuned for other videos. I have some cool things arriving in the mail. I plan to 3D print some enclosures, and thanks for watching.